In our previous video, we saw different aspects and also the order of execution of each of these aspects when they have a common join point. We also saw the success as well as failure condition and the order of execution. In this video, let's try to dive a little deeper into the order of execution and see how exactly the implementation within the Spring framework has taken place so that this order of execution was possible. Please watch the previous video for better understanding on this execution flow. So we saw in our previous video a basic after returning advice wherein we called the place order and then the actual advice was called. This can also be represented in this manner from the flow of execution which we saw. Business logic method executes first and then the after returning advice executes. And the general order of success execution was this, and the general order for execution in case of failure was something like this. Now we will see the order of execution in case of success in detail. There is a class called reflective method invocation, and this class uses these 6 objects. There is a method called proceed, and that method iterates from this list of objects, and these classes implement method interceptor. And this method interceptor has a method called invoke, and this invoke method takes method invocation. In our case, reflective method invocation. So what exactly happens is when the proceed method within this reflective method invocation is called, the index is initially set to 0 and the proceed method is invoked. Within this proceed method, the index is incremented. Now the value is 1. It checks if the size of the list is greater than or equal to the index. Here we are considering the indexing from 1 and not from 0 as we do in Java. So the first index is this expose invocation interceptor object. Since this condition is true, what it does is it fetches the object from this list from the index. In the first case, expose invocation interceptor is picked up and the invoke method on this object is called, and the object of RMI or reflective method invocation is passed to this method. Within this method, interceptor specific code is executed either before or after calling the proceed method. And here a recursive call to the proceed takes place. In the first execution, we know that the index I is 1. Now what happens? Index changes to 2 and this is our object which is being fetched. Again, the invoke method on that object is called, index changes, and so on. Once the index is 6, in a sense, after execution of this last object invoke method, the index changes to 7 and hence this condition is going to fail. In that case, the business logic method which we implemented executes. And once this business logic method completes, recursively whatever the methods were there, those will be completed because we are recursively calling the proceed method. Let's add some short forms for these reflective method invocation. Let's call this as RMI, and we will not consider this expose invocation interceptor because this interceptor just stores the state of execution before this advice interceptor's execution takes place, and hence we will ignore this in our execution flow. The aspect J around advice, this class will call the around advice and let's call it as around int for interceptor, and method before advice interceptor will invoke our before advice. Let's call this as before int. Aspect J after advice is responsible for after finally. So after int, after interceptor, after returning advice interceptor calls after returning advice. Let's call it as after returning int, and aspect J after throwing advice. This is going to call our after throwing advice. And let's call this as after throwing int. We are just trying to rename them so that it will be easier to understand in our next steps. So here we are using the renames of the list of objects, all 5 objects. We have excluded the first object, and here we need to have an eye on different places. So here you will see the logging, in a sense, the message printing whenever our advice is being executed, either advice or the business logic. And here the stack of the recursive calls will be stored and popped up accordingly. And this is the list of objects of our interceptors to be called. Initially, what happens here is rmi.proceed, or the proceed method is called. And within this proceed method, it goes to the first list around interceptor, and the invoke method of this around interceptor is called. And within this invoke method of around interceptor, there is a call to our around advice, and nothing else happens apart from that. Since we have a call to around advice is being called, and our around int is not yet completed, and hence it goes to the stack. Now here in our method, the first thing what we did was we printed around start. So that is what is going to reflect in our logging. And then jp.proceed. Here jp is nothing but remote method invocation object itself, this object itself. So when we call this proceed, it goes back here, and the next object from the list is being picked up before interceptor, and the around goes into the stack because the proceed is still executing. The next steps are not yet completed. Before interceptor is called, and within this before interceptor, there are two things that takes place. Invoke method of the before interceptor, a call to the before advice takes place, and then the proceed method is called again. When we call before, our advice is being executed here, which we have implemented, and within this advice what we did, we just logged @ before. That will be reflected here. Once this is completed, the pointer comes back to the invoke method of this before interceptor, and since we are done with this and nothing more happens here, let's remove this. The next step, what happens over here is rmi.proceed. In a sense, proceed method is called again. And since the invoke method in this before interceptor is not yet completed, it goes to the stack. The next in our list of objects is after interceptor. The invoke method of the after interceptor is called. Note that every arrow going out of this proceed always calls the invoke method, and every arrow coming inside here is always calling the proceed method. Here invoke method for this after interceptor is called, and within this after interceptor, the code looks something like this. There is a try and finally. Within the try block, rmi.proceed, in a sense the proceed method is called back, and once this proceed method is completed, in the finally block, our after advice is being called. And since proceed is called, we'll go back to the proceed method, and after int is added to the stack. Our next in the list is after returning int, and the invoke method of this is called again from here. Within this invoke method of after returning interceptor, a call to rmi.proceed takes place back to this, and once this is success, a call to after returning advice takes place. Note that this method throws the exception if there is some exception. Same case takes place here as well, same case takes place here as well, and here. We just want to propagate the exception if there is some exception. Now since RMI.proceed is called, what happens? The proceed is called back, and our after returning int goes to the stack. In our list, after throwing interceptor is there, the invoke method of after throwing interceptor is called. And within this invoke method, what happens? A try catch takes place. There is no finally here. Within the try block, the RMI.proceed is called, the same back. And if there is an exception within the catch block, this part of the code is executed. In a sense, call to after throwing advice takes place only if the object of this catch, the type of this catch object, matches the after throwing exception which we defined. Since a call to RMI.proceed takes place, it goes back. Now there is nothing in our list of objects to be executed. So what happens? It calls the business logic. But before, the after throwing int also goes to the stack. Business logic is called, and within this business logic, what we did, we were placing an order. To place an order, we just added an ID, add it to the list, and return the object. And during this time, what we did, we added a log. So business logic will be printed in our logs and return back. And since there is nothing going to happen here, let's remove this, and the pointer goes back to the proceed. And since this part is also completed, let's remove this. Now the execution takes place from the stack. After throwing interceptor is in the stack, it pops up, then the stack points to the after returning. Here in the after throwing, since there is no exception, this part of the code doesn't execute. The invoke method of this after throwing interceptor completes, and since it completes, we'll just remove it. And since every execution is completed from the after throwing interceptor, this also goes off. And the next thing in the stack is after returning interceptor. Pops up from the stack points to the after interceptor. Here in the after returning interceptor, the proceed is completed. Then a call to after returning advice takes place. So it goes to our method which we implemented, and within this method we printed after returning. So after returning is printed in the logs, and once this is completed, goes back to the invoke method. And since this part is completed, let's remove this, and after the call of this after returning advice, there's nothing to be executed in the invoke method. So let's remove this as well, and the pointer goes back. Since the after returning interceptor is completed, this also goes. Then the stack has after interceptor. It pops up and points to the before interceptor. Now the after interceptors proceed is completed. So the finally block should be executed now in the invoke method. Finally block calls the advice of after. So our after advice is called, and within this after advice we printed @after, and that is going to be visible in our logs. Yeah. Once this method is executed, it goes back to the invoke method of after interceptor. And since this is completed, let's remove this, and the finally block is also completed, and our invoke method of after interceptor is also completed. Let's remove this as well. Pointer goes back to the RMI.proceed or the proceed method. Let's remove this as well. The next thing in our stack is before interceptor. Pops up, the pointer stack points to the around, and we will execute the invoke method of before interceptor. Here RMI.proceed is completed. There is nothing more to be executed. So remove this as well. And since nothing is remaining here from the invoke method of before interceptor, we'll remove this as well. Now the stack has around advice, which is this part. It pops up and the stack points to the around interceptor and proceed method is completed here. The next line was to print around end. So logging will add around end and the method of execution for this advice is completed and hence it returns back to the invoke method of the around interceptor. And since this is completed, let's remove this. And the next thing in our stack is around interceptor. Pops up and the invoke method of the around interceptor only had this call to the around. This is also completed. And once this is done, the pointer goes back to the proceed and this is also executed. Once this completes, the response from this method is returned back to the caller. And if you see the logging, we had same set of logs what we saw in our execution when we were using our application. So around start, before, business logic, after returning, after and around end. Similar things will happen when we take the failed use case. Here at this point of time, an exception occurs, then the exception propagates to after throwing int, and since the exception occurred and the type of exception matches the type of exception the advice catches, and hence this part of the code is executed and exception is thrown back. Since exception occurs in this rmi.proceed, nothing happens here and the exception is sent to after interceptor. And since we have the finally block, the after finally is executed and exception is propagated here. There's nothing to execute here. Exception is propagated. Since the proceed method is throwing an exception, the rest of the code is not executed. Exception, exception, and the exception is returned. And that's the reason you'll see after throwing executes and after returning doesn't execute and around end doesn't execute. You can also see from the logs what we had in our application execution. So this was the detailed understanding of the flow of the order of execution when all the advices meet at a single join point. In our next video, we'll see each of the advices in a bit detail. That's it for this video. Thanks for watching.